Okay, so, all right, so we were talking about two different examples for SN1 and SN2. So let's go ahead and do them. I'm going to give you the same reactant here. So we'll start off with something like this. Okay, and let's get an alcoholide, and let's go ahead and react it with a strong nucleophile. All right, so hopefully you recognize this is secondary, and this is a strong nuke. Okay, what that means is this is probably going to proceed via SN2. So single reaction. All right, so the bromine's going to leave as this thing comes in. So shoop and shoop. But don't forget that this is going to be a backside attack because it's SN2. So the way that I personally would prefer to draw it is just draw the same thing, but instead of where the bromine was on a wedge, we'll put the resulting OH on a dash, if that makes sense. And then of course we'll have plus Br negative over here. Okay, so this would be like the SN2. Now let's say we have an SN1. I can do a better job, there we go. So in an SN1, again, we have a secondary, but I'm going to go ahead and react it with a weaker nucleophile like H2O. Okay, so in this case, remember the leaving group leaves. Making this planar carbocation. And now the water can come in. It can come in via the front, or it can come in via the back, and you'll get two results. In the front, you'll get this, and then because it's coming in the front, this will now be on a wedge. Remember, you have a nucleophile that's neutral, so you'll get a positive charge. Or the back, you get the same thing, but instead of the cis here, you'll get the trans. Don't forget that the Br, I don't know why I'm drawing all the dots. I'm trying to hurry because my dad called to let me know that my kids will be home in 3 minutes. Okay, so it's going to grab that proton, and you will be left with HBr in both situations. But an OH there, and equal amounts of cis and trans product with OH, and again, in both cases, HBr. All right, let's keep going like I got all the time in the world. Okay, the good thing is, remember we were talking about the various things that affect it. So primary, secondary, tertiary helps determine whether it's going to be SN1 or SN2. We talked about the strength of the nucleophile. The leaving group, thankfully, is going to be the same for SN1 or SN2. No matter what, if you have a strong leaving group, it's going to help the reaction and improve the rate. And then we have solvents. Okay. Polar product solvents are good for SN1 reactions. Hopefully this makes sense, because remember, polar product solvents switch essentially like the basicity, and it does come the opposite of what we'd expect. So SN1 reactions, remember, this is when we have weak nucleophiles. So if we have a polar product solvent, that's going to switch it and make it a slightly stronger nucleophile. Okay, so which solvents favor SN1 and which favor SN2? This just kind of gets you used to solvents. Notice, again, solvents. So in this case, we have an OH bond. This would be polar product, right? And we know polar product solvents favor SN1, the things with weak nucleophiles. Again, it's polar product because it is an OH bond. In this one, we have a polar A product. Polar A product is going to be SN2. And last but not least, we have this one, an OH bond again, polar product. So that's going to favor SN1. So when you write your reactions, you're going to wanting to be considering these. All right, let's put these together here. All right, let's see which one it's going to do. Just by being given these two reactions, we can determine if it's going to be SN1 or SN2 as the most likely reaction. Okay, in this first one, the first thing I look at is I notice that this is a secondary alkyl halide, which means it could be SN1 or SN2. But then I see this sucker. See that negative charge? This is a strong nuke. Okay, that makes me think, oh, it's probably going to be an SN2 reaction. But then I see DMSO, and I'm like, oh yeah, that's an A product solvent. Remember, A product solvents want SN2. So SN2, 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 this sucker is going via SN2, and you will get a reaction that's like this. And don't forget, it's going to be a backside attack. So when we're looking at this thing, I can draw it the same, but I'm going to put the hydrogen here and the methyl there to switch them, to make sure that we recognize that they would have switched. All right. And B, here I have a tertiary alkyl halide. It's attached to 1, 2, 3 carbons, so automatically that tells me, yo, this is going to be an SN1. But even so, this is also a weak nucleophile. Notice how it's neutral. There's no charge on it. And because of that, I know I'm going to get two products here. It's going to occur via, so this one was SN2. It's going to occur via SN1. So I will get the racemic mixture here. I'll get one with a wedge with a dash with the O, CH3. Don't forget it would initially bond and then that hydrogen would come off. And I'll get one. That one's enantiomer. Or really, actually, it's a diastereomer because this has 2 stereogenic centers. I can keep it the same and put the CH3 on there and the methyl group there. All right, both of these would have plus HCl because we had to take off that hydrogen. And this one would have had plus AACl minus. Okay, last but not least, we'll see how far I get before my dogs bark. Let's do this. Okay, so here I see a primary. I see a strong nuke. This one's definitely going to be via SN2. So an SN2 reaction would give me something like this. Plus Br negative. Here, I see a secondary, which means it could be anything. But then I see this negative sign, and I'm like, oh, that's a strong nuke. So this one was SN2. This one will go via SN2 as well. So when I draw it, don't forget, we're going to have that inversion. So you're going to just put that N3 on a dash, plus Br. For C, I see a tertiary iodide there. This is definitely going to be via SN1. Also, this is weak nucleophile. So after all is said and done, we're going to have methyl groups, and then this is going to be O to CH3, and we would have had to have lost that H to that. So it's plus high. How's it going? And last but not least, we have this one. I see that this is a tertiary That was SN1, by the way. I should be writing this. Tertiary, so I know this is going to be SN1. I see this weak nucleophile, so it helps even more. I see that the nucleophile has an extra hydrogen I'll have to take off. So you're going to end up with two products. Did I draw that right? Yeah. So one is going to have the methyl on the wedge still, and a dash to the OH plus HCl. And the other one is going to be the same thing, except the OH will now be on the wedge, and the dash the methyl group plus the HCl. So you'll get both of those as options. All right, y'all. I hope this helps, and have a great day. I did it. Yay. Bye.